Hello everyone, welcome back to the continuing adventures of doing things with a Chromebook, I guess. In the first part of this video, we gave it a clean wipe and did a fresh install of Linux on here and put xfce on. It was previously running Cosmic Desktop just as a bit of a test run, and it wasn't particularly well suited to the hardware. I don't think it ran fine, but it wasn't brilliant. I think xfce is a good match here. If you're curious what model of Chromebook this is, there'll be a link in the description. It's roughly from about 2019, I think, and if you know anything about Chromebooks, you will know what level of quality, let's say, the hardware is. Not good. So today, we are just going to be, it's going to be a quicker video than last time. We're going to be fixing some of the core problems that we have with having this kind of more custom hardware on a more general operating system. Because when you have Chrome OS on here, they've got their custom kernel, they've got all their custom firmware and things like that kind of solves all these problems. But when we go all rogue and start cracking it open, then obviously we need to kind of fix some of that stuff. So the main issue we have at the moment is that there's no audio at all. So an audio device is discovered. I believe what it's doing is it thinks there's a HDMI audio device, maybe two of them, and it's trying to output to those, and obviously it's not going anywhere. Doesn't matter kind of how much volume I give. If I play a sound test here, as you can hear, there's nothing coming out there. So we need to fix that because my son, who uses this laptop, is complaining at me because the sound used to work until I completely wiped it because of a YouTube video. So I'm going to fix that today with a custom kernel. Now, I will preface this by saying that this isn't a tutorial at all, mainly because the two parts of this video, the first part is going to be building the kernel, and I am not going to be really building it in a particularly professional way. I'm using a script created by someone cleverer than me that I don't 100% kind of fully comprehend, if you see what I mean. I know what what it's doing, really. I know in the broad strokes, but I wouldn't ever kind of say to someone, oh yeah, just grab a GitHub project, build a kernel and stick it on your laptop. The reason I'm using this is that I've gone through many iterations and tests of doing this with it, and it's it's never done me dirty, but I would always advise that you at the very least look very closely at any scripts that you're using to build something as critical as the Linux kernel for your machines. Let's give you a bit of information about kind of what we're even building here and what the project is that we're using. So let's just jump on the old internet here. Now we are using this project here. Chromebook is a general kind of project that is dedicated to getting Chromebooks running Linux and Windows, and this particular repo is a kernel for a very particular type of architecture that we have, or I should say, Stony refers to Stony Ridge, which is the architecture of the APU that's in this machine, the AMD system on a chip that deals with the CPU and the graphics processing, and also the audio, as it turns out, which makes sense. So this is basically a script that will pull down the version of the kernel that you want, apply patches that are in the patches folder here. Now this is there's one patch file, which is basically just kind of see it as like a reverse diff file. It's a diff file that tells the system how to change another file, basically. So everything in red, it's getting deleted. Anything in green, it's getting added back in. So there's various bits. This is the bit that I don't particularly comprehend. All I know is that it is pointing the kernel to different firmware and different bits, just so it's recognizing what the device is a bit more and assigning the appropriate drivers to it, I believe. I do know that there's definitely something funky going on with it, because I was doing some test installations of various distros, and there was one particular one, I can't remember the name of it, but it's one of those really opinionated Libre ones that doesn't have System D on it, and it during the install, it actually gave me a little pop up with a lecture about we can't detect your GPU, so it must need proprietary drivers. Find hardware that respects you. I was like, this is an AMD chip. Like, AMD have open source drivers, so yeah. So thanks for lecturing me over nothing, random distro that I installed for no reason. Anyway, that's besides the point. So really, this script kind of just formalizes that whole process, and someone who, Weird Tree Thing is the user that is maintaining this. They have all this knowledge, and they have put this knowledge into a script, and I am gratefully using it. So that's what we're going to do. We're going to actually build through the kernel now, and then I'm going to get the files and install it on the laptop and have sound, and that is going to be it. That is going to be the video. So let us start off by going to a more capable machine. So I am going to SSH into the mothership, the main PC of the Computer Man household. No, that's my NAS. Yeah. For whatever reason, this one machine, my main machine, doesn't recognize, or doesn't the host name doesn't resolve to its internal IP when I do SSH. I'm not entirely sure why. That's besides the point. So what we have got here then. So if I go into be in projects, because we've already got this checked out, and we are going to need to make one small change to the build.sh, so we can see the exact same files we just looked at in the repo. And I will take a look at the build.sh, because I will show you that I've made just a couple of changes here. Firstly, the change we need to make is the version number here. Now, if I was to just pop back over to the intranet, we go to kernel.org, we can see that the latest 6.6 release, which is the freshest of the long-term support kernels, is 6.6.66, which is fantastic version number. I hope it never gets updated. I hope there's no security vulnerabilities with this, so it never goes to 67. But essentially, roughly speaking, the version number 6 and 6.6, that is the kind of the almost the hard version, if you see what I mean. Like, if it was 6.7, it would have new features, whereas the third number refers to patches, security updates, things like that. So these long-term support kernels, these are all constantly updated, like maybe once a week, like maybe a little less often than that, because the main stable kernel obviously is getting the majority of the attention here. Basically, we know that this script was written for 6.643, I believe. Yep, 6.643. So we're pretty sure that upping this to 6.6.66 is going to be fine. It's not going to break anything, and actually it's going to be better because it's going to be a more secure kernel. So we'll just update that before we run the build. Now, other things that I've done here, I have just added a line to clear out the source and build directories just before we build, just because when I was initially messing about with this, I was compiling things quite like over and over again. Basically, I was trying to make some changes to the config file myself to no real avail. So I was doing a lot, and if those directories are there when you try to start the build, it hangs. So just clean that up there. I might pull that back. Yeah, I might send a pull request for that, but it's fairly minor. And then everything else. Okay, here we go through the patches directory, and it applies the patches to the kernel after it's downloaded the tarball, untarred it. And then it just runs through your normal process you do if you've ever compile the kernel, you first make the kernel with the make command, which compiles it, and then make modules, which generates the modules. Basically, the kernel comes in, well, let's say roughly two parts. I guess you have the kernel image, and then you have the modules, and then the modules. I believe both the modules and the kernel image get put into the init.ramfs file, which is also something that we're going to be dealing with. At some point, I owe you all like a proper video about the kernel where I actually know fully what I'm talking about. So once again, not a tutorial. Right, so that's basically all we need to do. We've already saved that, so we'll just quit here. No, we didn't save it, idiot. There we are. And we are ready to go. So I'm going to run the build, and it's going to take about 15 minutes, so I will speed things along. Just cut in from the lovely fast forwarding that hopefully I figured out how to do in the editing suite. Just in general, actually, I just want to talk about building custom kernels and kind of what I've kind of the thought process I have with them now that I've kind of done this a few times over. I think the first time you compile the kernel and get it installed and it works is quite like intoxicating. It's kind of maybe the first really like fairly advanced thing you do as a as a Linux user, especially if you kind of only starting to properly kind of power use it, or get close to power using it. And it can be quite intoxicating to the point where you think, well, I mean, clearly this is the correct thing to do. I should always be doing this. Like, how, what other, maybe I should, run the command that automatically turns off everything that isn't hardware in my system so I can keep it as lean as possible and it's going to be as fast as possible. And I think in general, that is a pitfall. If you're going to be if you're going to be compiling a custom kernel, it's better that you have like a really specific use case that is kind of like, if you're going to be compiling the kernel for a particular machine, it's better that your hands are tied, really. Like, you kind of have to do it, because then you're solving a problem that you have. You're not inventing a problem and then solving it with something really annoying and complicated, like compiling your own kernel and then having to keep up with compiling that kernel kind of over and over again, if you see what I mean. If you have that sort of wanderlust of always wanting the most up-to-date thing or the most optimized thing, there are distros for you there where people who know a lot more, are constantly creating their own spins of the kernel as it comes out, things like Kashi for like really optimized gaming kernels, and obviously Arch in general. Every distro really, like every distro has their build scripts probably where they make their own patches and their own config changes before they put it into an update. So I would in general just recommend against kind of getting too like over the top when it comes to custom kernels. It's really great if you've got a piece of hardware that is just needs it, like this does. Like, there is only one way to solve this problem, and that is a custom kernel and later on a script that we run, and that feels great. But on your main machines, if the default kernel works, then that is a blessing, because you can just let it update and just get on with itself. One thing I would actually recommend as well. I mean, everyone's like, I'm falling into the trap of that I don't like, which is kind of people giving you advice. But all that advice is just a big list of things that they have done because it ended up working out for them. So they give you it as advice. It's going to work for you. But I will say, in my experience, I started with, with messing around with the kernel for this laptop. That obviously gave me the bug. What I did then was kind of realize that I enjoy the process of assembling things, assembling bits of Linux together. So I just kind of dived into Linux from scratch and did that. That is possibly not, the way everyone should go, but it really did literally scratch an itch for me, because it you know, yes, you compile your own kernel during that, as well as literally everything else. Everything is compiled, and it is a superb way of just getting a knowledge of all the constituent parts, and it's really fun to do that. You can scratch all the itches you need of, like, I want to custom compile this, and I want to try these various flags and this and that, without it then being without it affecting kind of any important machines or important installations. And I don't know, might cut all this out. Feeling preachy, might delete later. And there we go. Told you it'd be about 15 minutes. Almost like I've done a test run of this. Right, brilliant. So if we now look in our build directory, we will see. So there's various bits here. We don't need everything. What we do need is the VM Linux image and the modules folder. These are the two things that we will be kind of copying onto our laptop and putting in the correct places. But both of those are contained within this kernel file. So what we'll do instead is just grab that kernel file over SCP, just as a slightly easier way of doing things. So we'll exit out of the main PC here, and what I want to do is just create a new folder to keep all this nonsense in, that we can delete later. Call it Stony Kernel. Right, so we're doing SCP, which is just CP but with SSH. Simple. Once again, we will grab this from our main machine. What was it? Was it 196? Hope so. And that lives in home projects. I can't autocomplete because I'm not on the. This is why you don't rely on autocomplete. Build, and then it was, and then it's kernel.tar.gz, and we just want to put it right here. So we'll just put a dot. Lovely. Okay. Take a look there. Right, so we'll untar this. And then we should just have the exact same files that we just looked at, but now on our proper machine, on our Chromebook laptop. Fantastic. Okay, so first of all, if I go into the boot partition and look what we've got there already, you can see these two files, the initramfs and the VM Linux image file. So these are both obviously for the stock Arch kernel that's installed. So we want to be copying our stuff into here. So if we just go back into Stony Kernel, and we want to move VM Linux to boot VM Linux dash Stony dash 6666. The name that you give these doesn't matter particularly. The only thing that matters is that we keep the name of the modules folder exactly the same, which we'll do next. But when it comes to kind of what you append your files with in here, it kind of doesn't matter. Just be consistent with it, and then it makes it easier to build the config file that actually points to it in the bootloader. Oh, we don't want to move, actually. Let's just copy for now. Yeah. Okay, fantastic. So sorry, I know I'm But there we go. We can see that it's now in there next to its brother, slightly bigger. Probably got more modules or more bits in it. Okay, so now if we have a look in the modules folder, we'll see a lib. So this maps directly to our own lib folder. There's a folder called lib modules. So if we go into this lib folder, oops, there's a modules folder, and then within here there's our folder full of modules for our custom kernel. So this just needs to be copied into lib modules basically. So we'll do cd copy recursive, because we're dealing with a directory here, and we want that to be in lib, and this needs to be the same. I've made this mistake before, given this a different name, and that's a bad idea. So here we are, sudo copy recursive this folder, and then if you just end this with a / on an existing directory and don't write another directory name, it will just copy it as is. So if we now copy that, if we go into lib modules, we can see where this lives now, and there it is, right next to our modules for the Arch kernel. Perfect. So now that the modules are in there, we need to run a command to generate our init_ramfs image. And that command is this right here. So we make init cpio -k for the kernel. This needs to match our folder in modules. So it's 6.6.66 Cultra. Oh god, it's hard enough to say, I can't even spell it. Chromebook -stony .g, and then we tell it what its file name should be. So we'll just auto-complete that, and so instead of Linux there, this will be what we want it to be. So in this case it's stony, so we'll give it the same appendment as the other one. So init ramfs stony -6666, and like I say, doesn't necessarily matter what that's called, because these two files are referenced in a config right now. So there we go, we got our files in there. So this next step is to set up the bootloader. As with the last video, we're using systemd boot for reasons that I went into in that video, but mainly because I know how to deal with it. I know how to use it. If we go into entries, we will see that we have our arch.conf. This was created in the last video. So let's just copy that as a base. Copy arch.conf, and we'll just call this arch-stony. This will be the conf file that we'll use all the time. So, you know, when I'm compiling this up to its next version, whenever I need to do that, I will keep using this exact same config file, because it's going to be pointing, we just change kind of where it points to, really. Do you know what? That's made me think. That has made me think. These file names shouldn't have version numbers on them, and that is because what we want is we want the bootloader to be pointing to consistent file names, exactly how the stock kernel does it. So if you notice here, this doesn't say Arch, or it doesn't say whatever the current version of the kernel is. It is more generic than that. So what we will do is we'll just make these simpler. So just vmlinux stony. I think this is a better way of doing this. And then we'll do the same thing with our init ram. Yeah, perfect. Right, so that, yeah, okay, that looks a little bit more, looks a little nicer, doesn't it? Okay, loader, entries. Okay, so now when we edit our arch stony conf, we just need to set this up. So this is the title as it will appear in the bootloader, and we'll just call this Stony. We want to be pointing it to VMLinux Stony, and the initramfs is initramfs Stony. This next bit we don't change because this is the UUID of our root root partition, and that is the same regardless of what kernel we're booting into. So perfect. Right, let me have a think if there's anything else that needs to happen. I don't believe so. So what I'm going to do is restart, and I will need to change over to shaky cam because a lot of the boot process is not going to be shown on my capture card. So reboot and go. So hopefully this works. I should see the rabbit, the hare. And then next up will be the system deboot menu. We can see there we've got Arch Linux Stony. I'm going to be really brave and I'm going to just press D on this, which makes this default. I'll just zoom in on that a bit. Okay. So now boot, things are looking decent. We are booting into Linux. Fantastic. I didn't reckon for this, but the my capture situation has slightly changed in that it's no longer mirrored on the laptop. So let's just hope this isn't complete disaster when I boot in. Okay, good. Yeah, we're back to mirroring. Fantastic. Okay, so nothing's different initially. We are going to do one more thing before we test our sound. We are going to run one more script that Mr. Weird Tree Thing has provided, and that is this one here, Chromebook Linux Audio. So the instructions here basically, this is just to tweak a few settings, get everything where it should be. The instructions say a full install of a supported Linux distro is required. Yes, okay, so we've got that one. And then it basically would just make sure that we've kind of everything is in place as it should be. So let's just copy this directly and let's get to it. Again, don't check out code and run it on your machine without reading it thoroughly and knowing what it's doing. Let's just put this in a software folder just to keep things neat. And I don't need to type that out, do I? Because, okay, yeah, git clone, Chromebook Linux Audio. Boom. And then, what was the script again? Setup audio. Excellent. Increases alta headroom. I think that's... there was an issue I was having where it was very stuttery. Like it felt like the CPU couldn't keep up, and I think that's what that fixes. But yeah, that's all fantastic. That is all. There's no errors there. I think we are good to go. So now's the time for the test. Excellent. Very satisfying. So there we have it. I can pretty much officially call this laptop back up to full working order after the big reset was done. XFCE is doing great. My son certainly likes using it. We have I've had to grab the software center from GNOME. It's not very good, but he likes to he's installing flat packs of various games and stuff like that and filling up this tiny hard drive, but that's fine. That's what it's there for. So yeah, now he can listen to Linkin Park. So he'll be very happy about that. But thank you very much for watching and continuing to watch, and I'll see you later.